high voltage diodes rated at 1.5 amps. While matching the diodes outlined on the PCB, install diodes at locations D1 through D7. D1 through D7, how many do they give us? 1, 2, 3, 4, 5, 6, 7. So we're going to install all of these diodes. And here's one. And there's a band on the printed circuit board. Let's get a little bit more light. And we're going to match that band to the band on the diode. So we'll just, again, gently bend over the leads with your hand, your finger. And there is D1. We'll bend those leads back. What was that beep? Oh, that was my meter telling me it's going to shut off. So there is D1. And let's install these and then solder them afterwards. So again, we bend over with our finger like so. And then we match the band to the printed circuit board. So D2, we don't really need to go in numerical order, but I am doing that anyway. And again, we want the diode centered in the picture, or the print on the PCB board, just for the sake of neatness. And now we want D3. Bend it over, bend it over. Match to the band. D3, the band goes this way, like so. Press it down onto the board firmly, and then push the leads over. And now we're on D4. Band is over here to my right, so the band goes to the right, and we center the component, and then we bend the leads over. That's 4, 3 to go. Where are the other 3? There's D7. D5, D6. So D5, D6, D7. D5, the band goes to my left on the board, so we orient the diode to the band to the left. As you can see, this is not electrical engineering science here. It's just trying to faithfully follow instructions. And D6, band is to the left, so we want to do the same thing. Center the component. And push the leads over. And then there is the last of the diodes. 57, where the band is kind of pointed towards me. So that's where the component goes. Tilt down. So now we are ready to solder all of those leads in one shot. So, am I in the shot here? There's a little bit of glare. There's not much I can do about that. And so now I'm going to just solder all these leads. Come on. You don't want to dwell all day on these leads, just until you see the you see the solder flow, and you also don't want to just gob it on for large quantities, because it's not aesthetically pleasing, could cause problems down the road. You want to kind of do the Goldilocks thing and just use just the right amount of solder to make sure that the lead is properly adhered and electrically connected to the board. This one maybe just a touch more solder. And then down here, last one. Now, since I'm soldering this with the component upside down, there might be some shifting where the component is hanging off the board. The instructions say to make sure that the component is flush, so we might have to reheat some of these leads. For a diode, I think that's okay. You do have to be careful if you're doing things like transistors, where you don't want to get the component too hot, because you could risk ruining it. So I'm just looking to see that these components are flush. This one is just a little bit off the board. Let's see if we can coax this one down. The part's going to get hot because it's small, but let's see if I can get away with it. Oh yeah, that hurt. Let that cool off a little bit. Yep. Okay, so now we go around the board and we snip. As close to the board as we can. We don't want to leave leads hanging out. That could present a shorting risk. So we want to get as flush as we can. Okay. This one, I knocked this over. Let's straighten that out. Alrighty, what's next? Double check your work. If any diodes are installed backwards, the circuit will not work. Oh, that's important to know. So let's just take a quick look here. We can see enough of the print on the circuit board to compare the bands on the component to where the band is situated on the board. And I see all these are correct. These two are correct. This one is correct, and by all these I was referring to these. I'm just tilting the board this way and that way so I can see the print on the printed circuit board versus where these bands are oriented. They all look good. Resistors R6 and R5 mount flush to the PCB. Install a 10K 2-watt resistor in location R6 and a 6.8K 2-watt resistor in location 5. Okay, so these two are different value resistors. While I can't quite make the colors out, I can tell that the color bands are different. So it said install a 10K brown, black, orange. This looks like that looks like orange. The orange I can see. So this should be 10K. We're going to verify that. This goes to R6. $10K. I don't know what that was. That in the shot? So this is what I was doing. Although I wasn't using my fingers because that can affect the measure, but it is measuring at 9.76 kilo ohms, which is good enough for 10K. And the 10K goes in R6. R6. Where are you, R6? R5, R6 is right here. Resistors don't really orient, except that, again, depending upon how the printed circuit board is oriented, you want, just for neatness sake, to orient your resistors so that they're reading left to right. So if this is top, from a standpoint of this is top, this is bottom, this is also the top side of the top, if you get what I mean, then for this one is going to be, if you will, vertically oriented versus these horizontally oriented. For vertical orientation, I will put the bands so that they're read from top to bottom. Now, how do I know what top to bottom is on a resistor? The gold band is the tolerance. So these other three values are indicating what the value of the resistor is. So I'm putting the gold band at the bottom. See that? And bend the leads like that. And let's solder these suckers up. And not quite flush on one side to the board, so we'll encourage that to sit. Okay. And this is probably R5 6.8K, which is blue, gray, red. Reading from left to right, it's blue, gray, red. I can't see the red. I do see blue and I do see gray, so confidence is high. But again, because of my color challengedness, I always double check with an ohm meter. 6.68 K ohms. Close enough to 6.8. And this is R5. So we'll bend these leads over. And again, based on the orientation, we will orient this so that the bands read top to bottom. And then press these leads over. And then we solder. So you can't get the orientation of a resistor wrong, quote unquote. They're not sensitive to which part is oriented which way. I'm just trying to be as neat and quote unquote professional for an amateur as I can be. Okay, and is that one on the board? It could go down a little bit. I probably don't have to do this. It's just my slight OCD nature. Nice and flush. Okay, where are we now? The photo below is of an older version. Oh, that's nice. The capacitors will be installed next. It is extremely important that the capacitors be installed correctly. If you put one in backward, be ready for lots of smoke when you first apply power to the PCB. Install two 47 microfarad 350 volt capacitors in locations C6 and C7. So 47 350, 47 350, C6 and C7, C6 and C7, where are you? This is C6. Now, how do we orient them? Looky here. See the negative? So we know the negative doesn't go to positive. It goes facing away from positive. And also notice the end of the leads, although you shouldn't completely trust this, but the positive end of the lead is longer than the negative end. So you got negative, the PCB board indicates positive, so we know that the negative side goes away from the capacitor. And for safety's sake, we don't want to heat these capacitors up too much when we solder them. We want to press them firmly down on the board. And I'm going to solder each one as I install them. Make sure I'm in the shot here. And there's 2. So now we inspect to see how well we did. There are the leads. There's the component. As you can see, come on. As you can see, it's flush. So we can cut these leads. We double check one more time. And it says plus or plus, meaning the longest lead is coming out on the plus side. And so 1 down, 1 to go. And the other one went in C7, correct? 47, 350 volts, C6 and C7. Okay, now here we have C7. We have the plus sign. So again, the negative goes away from the plus sign. Long lead in, pressed firmly against the board. Tilt these leads over. Clean our solder tip and solder. We don't want to hang out in the capacitors with the soldering iron for too long. Those look like good solders to me. So we have 2 of these capacitors installed. The minuses are both facing in the same direction. We are good here. Okay. Install 150 microfarad, 450 volt capacitors in locations C1 and C2. I'm going to guess that that's these. 100. No. So these must be 150 microfarad. Where did I go? 150 microfarad, 450 volt capacitors, C1 and C2. So that's how we know from the printing. And we have another minus. And so 150 C1. C1 is right here. There's the plus sign. We'll have the minus to go away from the plus sign, like so. And yeah, that's correct. Flush against the board. This one a little bit more difficult to move these leads out. They don't want to bend, so we tried. Just set that. Like that. Capacitor didn't shift, it's firmly against the board. We will cut the remnants. And the next one, C2, 450. 100 microfarad plus minus goes away from the positive, push it down so it's flush. It doesn't want to stay up. what can I use? Can't use that. Sorry for the bump. I don't see anything handy that I can use to prop this up. I guess we'll just have to wing it with the soldering iron. Hold it like that and then try to keep and again, that beep was my multimeter turning itself off. And we have our capacitors both oriented identically, flush to the board, no shifting. And now we trim the leads. Now we have 3 100 microfarad 350 volt capacitors, C3, C4, and C5, which is C3, C4, C5. Plus is all along the top. So minus orientation. There it is. 100 microfarad, 350 volt. So this is, well, this is C3. We'll go in numerical order, even though we don't really have to. Uh-oh. Got to get this call, guys. And I'm back. Long conversation. But you don't care because I was gone just a second ago, as far as you guys are concerned. Now let's solder up this capacitor. Would actually help if I put my glasses on, but it's a little fuzzy soldering. Okay, and now we will put my glasses on and inspect the results. And the results look good. So, snippy, snip, snip. One down, 2 to go. Positive to positive, negative sign in the opposite direction. Press against the board. Push the leads out so the part can't fall down. And make sure we're in the shot. I don't know how glary this is from the lights. I'm trying to improve the lighting from the last AC-4 upgrade project I did, because the lighting kind of sucked. I'm not a professional YouTuber, so I don't have the fancy schmancy lights and whatever. I make do with what I have available. I don't get any money for these YouTube videos. I'm not monetized. So, there. And so, snippy, snip, snip. And last, positive goes into the hole marked plus, negative goes in the opposite direction. Turn it over, press against the board, tilt out the leads, and we solder. Solder, solder, solder. Come on. We've got one more resistor. I wonder if that's extra, or are we going to put that someplace? We're about to find out. Doesn't it look pretty? I think so. Okay, clip up the leads. Double check your work. Double checking. You guys can double check with me. If I've made a mistake, I'm sure you're screaming at your monitor. No, don't. This one's not. That one's. I think that's all right. And let's see, is there anything else? This completes the assembly of the PCB. Set it aside until called for. Have I missed a resistor? What about R4? Did I miss R4? 1K, brown, green, yellow. Is that brown, green, yellow? I don't know. Let's see what this is. Is it 150K? I may have skipped over this resistor. That's scandalous. Yeah, 150K. Where'd that go? Install one 150K 3-watt resistor at location R4. Okay, so this is a good example of double checking your work. You should not have any extra parts left over, so this is R4 here, and we need to install this resistor. And again, since this top, I'm going to install it like that with the silver band, which is the rating of the resistor, so that we read the resistor value from the top down. So use this as a template. So that one, bend that over kind of like that. And then install kind of like that. With the silver band going towards the top of the bottom, so it looks like that. So you're reading the value top down. It's centered. And so we tilt out the leads. And we solder the leads. Oops, mistake. This is why see the mistake? The mistake is that the resistor is not standing off the board. So we want to encourage this. Glad we didn't cut that off, eh? That would have been a groaner. I gotta use this clippers to push down because the lead gets too hot. It's not fully where I want it to be, but let's do the other side now. looks okay. Maybe a little too far out. Life sucks sometimes as a perfectionist. Yeah, I like that. Okay, just run a little bit more solder. Make sure we've got a good connection here. And I think we do. That was a nice save, eh? And I think we can safely do the snippy snip snip now. Oop. As close to the PCB board as possible. And so there you have it. The finished high voltage board, which is going to replace a lot of the guts of the AC-4 50 some odd year old guts. So for those of you that haven't seen my other video using an older version of this kit, just to show you quickly, because I'm going to end this particular recording here and we'll resume later. I'm going to be cutting out a lot of this stuff. These capacitors down below, you can see where they come out the other side, these three are coming out. I don't think I'm going to need to remove the two that are up here, but we're going to electrically disconnect them from the power supply or from the cord. I'm not going to upgrade the cord simply because I don't have replacement at the moment. That may be a future project for a future time. My other AC-4 is also just a two-prong, not a grounded polarized cord, and maybe I'll worry about that some other day, but I'm not going to get into that with this. So we're going to snippy snip snip some of these components out. These diodes will come out, the pots will stay in, and the fuse will stay in, the fuse will stay energized, and we're going to run some wires. We're going to remove some wires, and we're going to run some other wires, as well as remove these capacitors as I mentioned. But we will save that for the next segment, and we're going to stop it here with the what I believe to be the successful construction of our board. What's going to happen next for this is we're going to be soldering a, where am I here? We're going to be soldering a series of wires as the instructions call for them. And the wires, this board will fit in here somewhere once the capacitors are removed in their space. and then the wires will come up through one of these holes in the capacitor, one of these capacitor holes, and then run where it needs to run, so that we are getting the right power off the right taps of this big transformer. And so that's the next phase. And so I'm going to stop it here, and we will consider this part 1, and part 2 of chopping this thing up will be next. See ya. Bye.